Welcome. We will be learning AVR microcontrollers in this series of tutorials and how to use them for robotics. Initially, we will see what are the basic differences between the AVR and conventional microcontrollers like MCS51 family, and then we will proceed on seeing how to use the basic ports on the AVR and how to do data input output using them. So let us see basically what are the differences between the AVRs and MCS51 families. What are the major differences that makes you, have a favor towards the AVR. So basically the most major difference is the speed. In MCS51 architecture, there are multiple clock cycles are required for executing one instruction, whereas in case of AVR, almost all instructions are executed within one clock cycle. So that's a major advantage. MCS51 runs at say 33 MHz, but actual instruction execution speed is hardly couple of megahertz, not more than that. Whereas in case with AVR, it executes instruction in every one clock cycle. So we get the 16 MIPS throughput at 16 MHz. 16 MIPS means 16 million instructions per second at 16 MHz. Yes, it is not that all instructions are executed within one clock cycle. There are certain instructions like jump, call, return, etc. which need multiple cycles. But since most of the instructions take one cycle, it has certainly better performance than the 8051 or MCS family controllers. Then the second thing is regarding the peripherals. What are the peripherals available? In the conventional 8051 like 8089S52 or something, we have very limited set of peripherals. For example, ports are limited. Not all ports have the pull-up registers. Then the second thing, timers, counters, limited number of them. There is no SPI communication feature available. USB devices is not available. Then PWM controlling is also at a very basic level, or it is not available at all in many of the models. Whereas all these features are there in the AVR. So therefore it makes a better choice for robotics and applications. So let us start with the basic introduction to AVR. Well, let us have a look at the detailed features of AVR. In this series, we will be concentrating mostly on Mega 16 microcontroller. The name is 80 Mega 16. Where the 16 stands for the 16 KB of flash memory. We will see the basic features of this controller. Well, let us have a look at the detailed features of AVR. In this series, we will be concentrating mostly on Mega 16 microcontroller. The name is 80 Mega 16. Where the 16 stands for the 16 KB of flash memory. We will see the basic features of this controller. AVR is based on Harvard architecture. That means it is having separate memory and buses for program and data. It helps to maximize the performance and helps the parallelism inside the AVR. When the instruction is getting executed in AVR, the second instruction is pre-fetched during the instruction execution. So you get the double performance. It is called a single level pipelining that is implemented in AVR. So it is basically a Harvard architecture processor. It is an 8-bit controller. That means all operations are limited to 8. High performance, 16 MIPS at 16 MHz. It is having a large flash memory, like 80 Mega 16 is having 16 KB of flash. It is having on-chip non-volatile memory, that is square ROM, wherein you can store the settings of different applications or whatever device or whatever product you are making. Then the Mega 16 is having two 8-bit and one 16-bit timers or counter units with total 4 PWM channels. With PWM channels, you can control the speed of motors, or you can use them for illumination purpose, or even you can use them for sound generation. It is having on-chip SPI interface. SPI interface is serial peripheral interface. This interface can be used for interfacing the MMC cards to the microcontroller. Or it can also be used for interfacing SPI I/O expanders. What are SPI I/O expanders? A controller will be having limited set of input outputs. In case of Mega 16, it is having 32 input outputs. So SPI I/O expander can be used to increase number of IOs available. It is basically a chip which communicates to the microcontroller with the SPI protocol, and it gives you the additional 16 or 32 input outputs, which you can use for controlling different devices. Then it is also having a support for I2C protocol on chip. With that you can interface I2C square PROM or any other device which uses I2C bus. Now the second thing, then one of the most important thing for robotics application is the analog to digital converter, because it reduces great amount of hardware used for making infrared sensors. AVR is having on-chip 10-bit analog to digital converter with 8 channels. Well, now these are all features. Then there is one more important factor along with all these features that needs to be considered. That is the cost. Cost of the AVR is quite comparable with that of MCS5 controllers. Regular controllers we get just for 35 to 40 rupees, whereas AVR is slightly costly at 100 rupees. But compared to all these features, we can definitely go for AVR. So these are the basic features of the AVR controllers. Now let us move on. So now let us see what are the tools required for using AVR. Now the basic and most important tool is the compiler. Obviously we cannot go for assembly programming at this stage, because assembly programming is extremely tedious and time consuming. So we will be using C language for that, and we will be using the Win AVR compiler. Win AVR is open source C compiler for the AVR. It is basically a set of command line utilities for linking, compiling and all those things. But then we also need a good IDE where when you want to write a good programs using a C language. So that IDE is the Eclipse IDE. This IDE stands for Integrated Development Environment. In this you get a nice editor with syntax coloring and all that facilities which will highlight the errors and the mistakes in your program when you compile the program. And WinAVR is a set of command line tools which this IDE will use to compile your C program. And also this IDE requires one plugin called as the AVR Eclipse plugin. When you insert that plugin into this IDE, it becomes compatible with the WinAVR and you can use that. So we need basically 3 tools. First is WinAVR, second is Eclipse IDE, and third is AVR Eclipse plugin. The CD which we will be giving it to you, the CD will be containing Eclipse installation. You just have to copy paste it onto your hard drive. It will be equipped with the AVR Eclipse plugin. So you just have to extract it and start using it. That's all. Then the second thing that is required, once you write a program, compile it and generate a hex file out of it, is the burner. Obviously you have to burn the program into the device. Which burner to use? There are 2-3 options. One is using Bonnie software and in-system programmer. ISP stands for in-system programmer. Parallel port based or serial port based. They are very simple to make at home. You can easily make them using the diagrams provided on the CD. Use the Bonnie Pro and burn your hex file into the microcontroller. And more sophisticated and the better one is using the USB ASP. Better way to program AVR is using AVR Dual and USB ASP. USB ASP is the USB based AVR programmer, and AVR Dual is the software, command line software which we will use to burn the files into the AVR using this. USB ASP is basically a good choice because nowadays none of the laptops have serial ports or parallel ports. So I would suggest you go for USB ASP. And obviously you need some breadboards and wires to try the things out quickly on your own. Okay. Now we will start with the basic introduction to the input-output ports. Before we move on, we have to remember certain points. Whenever I say a port, since from starting of this tutorial I am saying port. What is this port basically? A port is set of 8 bits. Since it is a 8-bit controller, if it is a 16-bit controller, it can be called a set of 16 bits or 32 bits. So a set of 8 bits is called as a one port on the controller. That port will be used for communicating with the external world, like reading digital data from the outside or writing digital data to the outside devices. Then the second important thing that we have to remember, since AVR is an 8-bit controller, the width of all registers is 8-bit. So whatever thing that you access, whatever thing you do in the AVR while writing the program, everything is the 8-bit access. There is no 16-bit access. Yes, there are certain registers which are having high and low counterparts, two different parts, high and low, that you have to access using different 8-bit instructions. While writing a C program, you don't have to bother about all these things because compiler will take care of it. Then the third important thing that you have to remember is every bit in the port related register. For example, a register called as port A. Every bit in the registers which are related to the ports directly corresponds to particular port P. Means what? For example, bit 0 in the port A register is directly connected to the port A.0 pin on the controller. So whenever you write or read any values in these pins, that status gets reflected quickly onto the pins. Okay, so whenever I say a certain bit, whenever I say certain bit number, that you have to remember that okay, that bit number corresponds to that particular bit location into the port register. So this is one-to-one correspondence. Bit 0 corresponds to pin 0 of port A, bit 1 corresponds to pin 1 of port A, bit 7 corresponds to pin 7 of port A, and so on. Then one more thing that you have to remember is the direct correspondence between the hexadecimal and binary numbers. Like for example, 0xFF can be written simply as 111. By remembering this correspondence, it will help you a lot while programming the controller in C language, because it is very easy to convert these two numbers. Upper 4 bits of the 8-bit binary number will represent this one, the higher nibble of the hexadecimal number, and the lower nibble of the hexadecimal number will be represented by these lower 4 bits of a binary number. So there is a direct conversion. Whenever you want to write something, either you can use this or this notation. But then how to use this notation? Whenever you want to write an hexadecimal value into the register or a variable, you write x equal to 0x and then hex value. 0x stands for hexadecimal. It tells the compiler that a value following this 0x will be a hexadecimal value. This x is a small hex. This x is a small letter x, not the capital one. This is not correct. You have to write 0, small x, and then the hexadecimal value. Now suppose if you want to write a binary value, then you can write 0, small b, and then a binary number. Say for example 1010. With these two notations, you can easily switch between hex format or binary format. If you write simply like x is equal to 105, compiler will interpret this as a decimal number. So these are the few things that you have to remember when you write a code into the C program. So these are the few things that you have to remember when you are writing code for AVR controllers. Okay, now let us move on, and we are going to see how to actually use this port A or any port on the AVR and how to do input output using that. So now let us look at this input output business. There are basically 3 registers associated. Mega 16 is having 4 ports: port A, port B, port C and port D. Every port is having 3 registers associated with it. What are they? DDRX, port X, and pin X, where X stands for A, B, C or D. Mega 16 is having 4 ports, and higher controllers are having even more ports like A, B, C, D, E, F, G, H, I, J, like that. More the controllers which are having more number of pins will be having obviously more input-output ports. So these 3 registers, DDRX, port X and pin X, are associated with every port. In order to use a particular port for reading input or writing the output, we have to understand the function of these 3 registers. Unless you configure the port properly, you won't be able to use it for for writing the output or reading the input. So let us see how to configure these registers. The first one is DDR. Data direction register for port A, DDR-A. As the name implies, data direction register configures the direction of the port, whether the port will be used for input or whether it will be used for output. That setting is done by the DDR register. Whenever you say DDRX.N equal to 0, that makes corresponding port pin as input pin. And in order to configure port pin as an output pin, you have to set DDRX.N to 1. Look carefully to this notation. DDRX. X stands for port A, B, C, D, whatever you are using. Dot N. N represents the bit number. Bit number like 0 to 7, it can be anything. Like port DDRA.0. This is not valid when you are writing into the compiler. This is just for the sake of understanding. Whenever you set a particular bit in the DDR register to 0, that particular pin becomes the input pin. And whenever you set particular bit in the DDR register to 1, that particular pin becomes the output pin. That is as simple as that. DDR, data direction register, used for setting input and output. DDR, data direction register, used to configure the port as either input port or the output port. Now let us have a look at some examples. If you want to make all pins of port A as input pins, then how to write it? Then you will have to write as DDR-A equal to 0xFF. Sorry, this is wrong. Then you will have to write as DDR-A is equal to 0x00. This will make port A all pins as input pins. If you want to make all pins of port A to output, then how you will write it? Simply FF. Another example. Suppose you want to make alternate pin as input and output. How to do that? DDR-A is equal to 0B 10101010. So now alternate pins will be input, output, and so on. Suppose you want to make lower nibble of port B as a output and higher nibble as input. How to write it? 0B 0001111. This kind of configuration is many times used for interfacing 4x4 keypad to a particular port. Like you make the columns as outputs and rows as inputs. So you send some data onto the columns and read the data from the rows to check which button is pressed. Now the second register that is associated to the ports is pin register. Pin X. As the name implies, port in register. X stands for ABCD, pin A, pin B, and so on. Pin register is used to read the data from the port whenever port is configured as an input port. So you have to remember that pin register is used for reading the data from the port pins, and it is associated directly with the port pins. Like for example, if you want to read the data from port B, how you will write? You can write it as X is equal to pin A. X is equal to pin B. This will read the data from port B into the variable X. Obviously, before writing this instruction, you have to remember that you have to make port B as an input port. If you don't, you won't be able to read the correct data from the port pins. Now there are 2-3 steps that you have to follow. Whenever you want to read data from the port, you have to make sure that you are configuring it as an input port. Configure port as input. Then read the data. If you have not configured the port as input and you try to read the data using pin X register, what you will get is the data that you had written into the port register of the port. Because this pin register directly reflects the values onto the port pins. If you have not configured it as an input, it will give you the data that has been previously outputted on the port. Whatever I am saying, is it understandable? Okay. Now there are two different kinds of input modes. One is tri-stated input and second is pull-up. What are these modes that we will see shortly when we come to the port register? So far we have seen two registers, DDR and the pin. DDR is used for configuring the data direction of the port, input or output. Whenever you set a particular bit in DDR to 0, particular pin becomes input. Whenever you set a bit in DDR to 1, particular pin becomes output. The pin register is then actually used to read the values on the port pins. Now there is a third register. Now there is a third register, that is DDR register. Now we will see the third register, that is port register. Now this is where it gets slightly confusing. This port register is having two different functions. Whenever a port is configured for output, this register, that is port register, is used to write the data onto the port.